All right, we're going to graph exponential growth functions today. Exponential growth functions look like this right here, where your x is your exponent on your base. A is going to be some number that does a vertical stretch or shrink, like you're used to seeing. All our graphing rules still apply. And let's go do some. Here's everything you need to know right here in one slide about what you're doing. The parent function is just y equals b to the x power, where b is bigger than 1. That's why it's growth. If b is less than 1, it becomes exponential decay instead of growth. And the general shape of the graph looks just like this always. A couple of things here. The x-axis is an asymptote, which means the curve is getting closer and closer to it, but it's never going to touch it. It's also going to rise from left to right. It's going to pass through 0, 1 all the time, because if anything to the 0 power is 1. If you put in the number 1 into b, 1 in for x, whatever b is going to be your next point. And we can find more points too. The domain all day is going to be all reals because your graph is going left and right forever. Your range on the parent one is going to be y is greater than 0 because the whole graph is above the x-axis. So that's an important slide. You got a lot of info on there, and those statements are going to be true all day. Okay, time example here. It says graph y equals 2 to the x power. I went ahead and took the time before I made this so it'll be a little shorter. I made an xy table right here, and I'm going to plot these points. Basically, I plugged -2 in for the x, -1 in for the x, 0 in for x, 1 and 2, and I got those values for y. When I played at -2, I got 1/4 because remember a negative exponent flips it, so it gives me a fraction. So I'm going to go -2, 1/4. I'm going to try to plot these. -2, 1/4 is about way down there somewhere. -1, 1/2 is about right there. 0, 1 is always goes through there. 1, 2, 2, 4. And you can see the shape it's taking. If you connect the dots, la, la, la. Let me change colors real quick so you can see it, hopefully. I'll try to hit them. It does something like that. And that's what the graph's going to look like. And again, domain is all reals, goes left and right forever. Range is y is greater than or equal to 0. Okay, let's try another one here. Y equals 1/2 times 4 to the x. Now, think about what we said a second ago. Instead of making an xy table every time, let's always plug in 0 because it's very easy to plug 0 in right there because 4 to the 0 power is really 1. 1 times 1/2 is 1/2. So remember I said it always goes through 0, 1? Well, the reason this one's going through 0, 1/2 is because the 1/2 is a vertical shrink. Instead of it going all the way up to 1, it's just going up to 1/2. Let's also plug in the 1 for the x every time. Because if I plug in 1 right there, 4 to the first power is 4. 4 times half, or half of 4 is 2. So we go to 1, 2. And that's really all I need because I know the x-axis is an asymptote. So it's going to do something like, the graph's going to do this type of thing. And that's good enough right there. Okay, this one, y equals -5/2 to the x power. Couple things here. First thing is it's got a negative in the front, which means it's going to be a reflection across the x-axis. It's going to be flipped upside down, basically. Let's plug in the same 2 points. Let's plug in 0 for the x. If I plug in 0 right there, anything to 0 power is 1, but because the negative sign's in the front, 0, -1. So I'm going to put a point at 0, -1. If I were to plug in 1, anytime you plug in 1, 5/2 to the first power is 5/2, but it's going to be -5/2 because there's a negative in the front. So 1, -2.5 is way down here. Connect the dots, la, 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 just like that. And there it goes, the reflection. Now, this time the domain is going to be all real still because it's still going left and right forever. But now the range would be from -infinity up to 0 because, or you could say y is less than 0 because the whole graph is below the x-axis. A couple more. All right, last one here says graph y equals 4 times 2 to the x minus 1 power minus 3 until domain and range. One thing about this, I'm going to try to graph this without doing a whole lot of work. Let's see what happens if we can do it. First of all, it's been shifted down 3, which means my asymptote is not the x-axis. That's that red line I'm drawing right there. That's my new asymptote because it's been shifted down 3. Let's see what else happens. Usually it crosses 1 above right there, 0, 1, which would be my new 0, 1. But this has been shifted right 1, so we're going to go right 1. But there's a 4 in the front, which is a vertical stretch by 4, so that's going to actually be 4 units above my asymptote right there. All right, so that's my new 0 point. So to find my other one, I'm going to go 1 right beside it, which means I'm going to plug in 2. If I plug in 2 there, the great thing about plugging in 2 for my exponent, 2 minus 1 is 1. So that means that's still 2. 4 times 2 is 8. Minus 3 is 5. So I'm going to go to 2, 5. 1, 2, 3, 4, 5 right there. While it's not drawing, there it is. And I'm going to connect my dots, la, la, la. And it's going to look like this right here. It's going down, down, down. So it's going to get closer and closer to the asymptote. Just like that. Now it also says type domain and range. My domain is all real numbers because it's going left to right forever. So my domain will look like this. My range, a couple of ways you can write it. You could say y is greater than -3, or you could do it this way, -3 up to infinity. Notice I put parentheses because it does not touch the -3. There's your domain and range. All right, one more skill here. Last thing, compound interest, which is an awesome thing when you're receiving it. Compound interest is how much money you get after a certain amount of time. Here's the formula. Make sure you write that formula down. P stands for principal. A stands for final amount, by the way. P stands for principal. Principal is how much money you start with. R is your interest rate you're getting. N is how many times per year it is compounded. You can see it right there. T is how long you leave it in. So one more time. P is principal. That is how long. That's how much money you start with. N is how many times per year it is compounded. They will always tell you that. R is the rate you're getting. T is time, which is how long you're going to leave it invested. Okay, let's try one here. Okay, it says you deposit $4,000 in an account that pays 2.92% annual interest. Find the balance after 1 year if the interest is compounded quarterly and daily. So there's two problems here. Part A, the amount is the principal, how much we started with, 4,000 times 1 plus the interest rate. Now your interest rate, you got to change it to a decimal. 0.0292 over N. N is how many times per year. It says quarterly. Quarterly is what you think, 4 times a year. The exponent is NT, so it's 4 times T. The time is 1 year, so just 4 times 1. And I'm going to take that whole thing and be very careful, and I'm going to punch it in my calculator. I'm going to punch it in. I got this much money right here, $4,118.09. You might want to plug that in your calculator as you're watching this. Maybe pause it. Make sure you get the right answer. It's a lot to plug in. Make sure when you plug that in that the fraction that is inside the parentheses has its own parentheses. All right, let me try part B here, and we'll close up this video. Come on now. Okay, part B. A equals same amount, starting amount 4,000. Everything's going to be the same except for the N. The interest rate's still the same. The one's still the same. All this stuff's the same except it's compounded daily. Remember, N is how many times per year it is compounded. There are 365 days in a year, so I'm going to put 365. Outside, it's NT is your exponent. Time is still 1 year, so you just punch all that in your calculator. And it should be a little bit more because the more times a year you compound, the more money you get. Let me punch it in. I'll be right back. All right, and this time I got 4,118 and 52 cents. If I were you, again, I would punch that in and make sure you're good on how to punch it in your calculator correctly. It just hit me. I said I'll be right back. It came back immediately because there's no pause in the video. So anyway, I'll see you tomorrow. We'll work on all this stuff. Hopefully it wasn't too bad. And just exponential growth. See you. Bye.